Hi, my name is Alex. Today we will build a pipeline that can query a genetic data and provide outputs in text and chart format simultaneously. We will start by adding AI agent. Tool agent is fine. A simple chat model. Simple memory. BigQuery tool. First, BigQuery to execute the query itself. And another one to get the table schema. We will add a QuickChart tool for the interactive plots. Let's set up all these tools one by one. First, let's set up AI agent. Here, very important is system message. Let's define a role of this agent. The role of the agent will be querying the database using BigQuery. Why we're using BigQuery? Because there are open source genetic datasets that we can easily use. Second, we will describe a target dataset. We will use human variant annotation. This one is the simplest to understand. I will show you shortly what is there. Also, we will ask the agent to always wrap the dataset name in backticks for every SQL query. They look like this. This is one of the rules of BigQuery SQL. Then we will ask the agent to follow the workflow strictly. First, we will ask the agent to go and list tables using the tool we've just added, BigQuery tool, get database schema and tables list. We will ask the agent always call this first to retrieve the full list of tables and schema names. This is very important so that the agent knows what kind of data structure it works with. Second, we will ask the agent to generate a single table Google SQL query. Single table because in this particular data set there are no relationships between table and our SQL query must work within a single table. That's why we will ask agent to choose one table from the inputs schema without joins, no subqueries across tables, and only reference columns that appear in the tables column list from the input schema output to prevent errors. Few other tricks is to prefix the table with its exact schema name, because this is the requirement of a BigQuery public datasets, a full path like this BigQuery public data, human variant annotation. So we're talking about this prefix. And we will add a limit 30 to the end of every query, because BigQuery charges us for the amount of data requested, and sometimes this amount will be too big. We ask the agent to write the SQL in a valid Google BigQuery standard SQL. Next, we are asking the agent to run the query using the tool execute SQL query, which you saw previously. Execute BigQuery. Execute BigQuery query and craft the textual answer to output the result in the form of a text. Summarize the result set in plain language, counts, top n, average, etc. And then build a QuickChart bar chart with a QuickChart tool. QuickChart tool is this one. We are asking the agent to use the same result set, and we set up the chart configuration to matching this template to edit labels and data as needed and to build a bar chart. And the data must consist from labels that will be substituted further with labels from the output, and the data sets. These are the X, and the label is what kind of a metric we're trying to show. And then we're asking the agent to encode the JSON and embed it exactly like this in an image. Over the course of interact with the agent, we will see a couple of glitches. So we introduce a number of constraints, like we are using only tables and columns that appear in the input schema output, to never query more than one table or use any kind of joins. Then we're asking agent to always generate chart via QuickChart tool, to always include the schema prefix in the table reference. As I mentioned, since we're using not our own hosted dataset, but rather BigQuery public data set, we need to append this prefix before the table name, and always limit results to 30 rows. The final response must use a markdown image lined with the QuickChart URL and text. And the SQL must be a valid BigQuery standard SQL, because they have some specifics. So now our agent is done. Let's set up OpenAI chat model. As you see, I already have account here, but let's imagine that I don't have an account, and let's set up it from scratch. For this, we will add a new credential, which requires us to input API key and URL. To get an API key, we have to go to platform.openai.com, log in. There, I will create a new secret key. We will copy the key and insert it here. Our connection is successful, so everything should work. To execute a BigQuery SQL queries, we need to first set up a BigQuery account. As you see, I already tested it, but again, for the sake of experiment, we will delete both of my accounts there and we will create a new credential. I recommend to create a service account. I earlier tried OAuth 2nd and it didn't work for me. To create the service account email and a private key, we have to go to Google Cloud, log into console, go to API and services, check that BigQuery API is enabled. In my case, it is enabled. I enabled it earlier. In your case, you will probably see enable button here. Please click it and continue. I am and admin, find service account. So we decided to create a service account here. Service account is a special non-human account for services and applications. As you see, previously I created the service account. Again, for the clarity of experiment, let's remove it and create it from scratch. So let's click create service account. We should give it a name. We already got an email address. Let's copy it and insert here one of the things that we are asked for. Another one is a private key. Let's create the service account. After a few seconds, we should see our service account in the list of service accounts. To find this key in JSON, we go to key management and let's create a new key. We are creating a JSON key. Download it to our PC. Let's find this file. Here is how this file looks like, and here we can find private key. We copy everything except brackets. Let's save it. We see that the connection is successful. Now we see that this BigQuery account is connected. Let's set up the tool description manually. We are working with the execute BigQuery query. This is the tool that submits a SQL query generated by the agent to the BigQuery. So what it does, it gets all the data from BigQuery and make sure you append the tables with correct schema. Every table is associated with some schema in the database. We also can find our project ID. Let's input our project ID here. One more thing, we need to add SQL. Our SQL query is a result retrieved from AE, a SQL statement, so it will be a SQL query generated by AI. Now let's check our data sets in BigQuery. For this, we need to input a BigQuery in our search account, look for human variant annotation. We can ask for a preview to more or less understand what kind of the data here. ID of a chromosome, start and end, numbers of a sequence, reference basis, so the one in a basic genome there, and alternate basis is the mutation, so it's single nucleotide polymorphism, so A replaced with C. This is a variant ID, ID of this mutation and mutated species, quality of a read, code names in other external databases, and other features that we will later use in our analysis. Let's get back to our agent and setup. Let's use the same credential. Let's again set manually the tool. This tool should get a list of all tables with their schema from the database. Again, it will execute a query. The project is the same. For the SQL query, we have to select table name, column name, data type to know how to work with this data, and is it a null or not. From BigQuery public data, human variant annotation, information schema, columns. Let's check what is it in the BigQuery interface. So you can see here that we will get table name, right? Many different tables, their columns, data types of these columns, and are they nullable or not. Also pay attention that here are some nested columns with many data types inside nested, so it's not as simple as you might think. Let's also select ordinal position. So ordinal position is a sequential number in the table of this column, table name and ordinal position. Now we're done with this tool. It should work. The final tool to set up is a QuickChart. Create a chart where QuickChart is fine description for us. We're looking for bar chart. As you remember from the system message from our AI agent, we will use labels from array generated by agent. Take results from AI, labels, we need labels, close all the brackets properly. Data, point to the data this time. We will not play with options with time, but you can see that here we can set up background color, pixel ratio, format, height, horizontal, width, etc., etc. Before we start testing our pipeline, let's remove a window buffer memory because we don't need it. Every query will be a separate entity, and make sure that within a QuickChart, our labels array and data array formulated as expressions. Let's close it and start testing from such query as how many variants are there per chromosome. We can see that all our nodes were executed correctly, and let's check the response. Here we can see the number of variants per each chromosome ordered from the first chromosome to the X, and Y, and also we see a bar chart. Unfortunately, the title is generic, but we see the bar chart along with the textual information. Let's try another query. For example, what are the top 10 most frequent variant types? Again, we can see that the top 10 most frequent variant types or bases and their frequencies are as follows: glycine, adenine, threonine, cytosine with their frequencies and some missing pairs, and the bar chart. Make sure to stay tuned, and I will meet you in another videos.